On the MCAT, projectile motion problems are simply talking about objects traveling at some kind of angle. And when we talk about something traveling at an angle, we need to break that down into its x and y direction. The x and y direction refers simply to the coordinate plane that you may remember from geometry. The x, that's your left and right. The y, that's your up and down. Incidentally, anything going to the right is considered positive. Anything going to the left, that's negative. Likewise with y, going up is positive and down is negative. So you can think of angular velocity like moving pieces on a chessboard. If I want to take this pawn here and I want to move him at an angle, essentially what I'm doing is I'm moving him up a few blocks and then right a few blocks. And you can see when I do that, I actually form a right triangle. For that reason, you have to be extremely familiar with the rules of right triangles. If you have a projectile motion problem on the MCAT, you will be using one of these triangles. Most likely, you'll be using what's called the 30, 60, 90 triangle. So you absolutely must remember the ratios of these sides. And it's pretty simple. The side opposite the 30, that's going to be your shortest side. The slanted side, or the hypotenuse, that will be twice as big as your shortest side. The medium side, the remaining side, will be your shortest side multiplied by the square root of 3. So if I found out that my shortest side was 10, my longest side would be 20, and my medium side would be 10 root 3. If a problem gives you the angle of the velocity, it will either be 60, 30, or 45. So you will be using one of the two triangles on the right. If the problem does not give you an angle, but only gives you the respective up and down velocity or the angular velocity, then without an angle, you'll be forced to use the Pythagorean theorem. And that is simply that a squared plus b squared is equal to c squared. And the only thing to remember with the Pythagorean theorem is that your c is always your longest side. Let's see how this actually works with the problem. So we have a ball here, and this ball is being kicked upward at an angle of 30 degrees. Since the problem mentioned 30 degrees, we know that we're really talking about a 30, 60, 90 triangle. So we can draw out our x and our y sides to make that triangle. The problem also tells us the initial velocity is 100. That's going to be the red line, or the original direction the ball is traveling. Since we know we're dealing with a 30, 60, 90, we know the ratio of our sides are 1 to square root of 3. Or, to make my math a little bit simpler, I can write it as x, 2x, or x root 3. Now we can see that my 2x side is actually 100. So I could write the equation that 2x is equal to 100. So x must be equal to 50, and x root 3 is actually equal to 50 root 3. You should also memorize that root 3 is roughly equal to 1.7. So 50 root 3 is approximately equal to 85. Now I can redraw my triangle. My initial velocity is 100 meters per second upward and to the right, which means that simultaneously going up at a rate of 50 meters per second and also going to the right at 85 meters per second. The question is asking us, how high will it be at its maximum height? So really all we're concerned about is its upward direction. When the ball is kicked upward, it starts off initially at a rate of 50 meters per second. But gravity is going to slow it down. How fast will gravity slow it down? At exactly 10 meters per second every second. So if we draw out its velocity as it goes upward, initially it's going 50, 1 second later it's going 40, 2 seconds later it's going 30, and then 20 and 10, and finally it reaches 0. In that way you could see it would take exactly 5 seconds for it to slow down from 50 to 0. Now we can figure out its average velocity. Remember, when numbers are evenly spaced apart, the average number is also the middle number. In this case, the middle number would be 25, right smack between 20 and 30. So now we know the average velocity, and we know it'll take 5 seconds for this ball to slow down and pause momentarily in the air. Then we can use one of the simplest equations that physics has to offer, and that is our velocity times our time is equal to our distance. Our average velocity we figured out was 25. Our time in the air as it goes up is going to be 5 seconds. So the distance we travel will be 125. So now we can draw a better picture of what's actually going on. We start the ball off at an angle of 30 degrees. It's going to the right at 85. It starts going upward at 50. Over time, gravity will slow this ball down. At its peak, it will have a height of 125, and we know it took us 5 seconds to get to that height. So this ball will travel 5 seconds on the way up and 5 seconds on the way down. Now the question could have asked us, what will be the total horizontal distance of this ball as it travels? We know gravity changes the vertical velocity. The question is, how does gravity affect the 85, or the horizontal velocity? The answer is, it doesn't. So the 85, ignoring wind resistance, and again, most problems on the MCAT will ignore wind resistance, the 85 will stay constant throughout the flight of the ball. We just need to know, how long will this ball stay in the air? Well, 5 seconds on the way up, 5 seconds on the way down. This ball will stay in the air for a total of 10 seconds. If we wanted to calculate the horizontal distance, we would again use the same equation that velocity times time is equal to distance. Our horizontal velocity is 85. The total time the ball is in the air, 5 seconds up, 5 seconds down, is 10, giving us a total horizontal distance of 850. So here's another great projectile motion problem. So we have this deer that's going to try and cross this distance of 20 meters. We've already established that when the deer jumps, his horizontal velocity is not going to change. So if we want to figure out how long he has to stay in the air, we could simply pretend that he's going to run straight across. And then we use our equation that velocity times time is equal to our distance. So we know our velocity is 10. That's not going to change. Our time is we don't know. The distance we're traveling is 20. Solve for t and we get time is equal to 2 seconds. So now as this deer jumps, we know it will have to stay in the air for 2 seconds in order to cross this ravine, which means it's going to spend 1 second on the way up and 1 second on the way down. 1 second up, 1 second down. Say I took a second deer and I'm going to drop him straight down at the exact same moment that my black deer over here is at the peak of his jump. The question is, which deer will hit the ground first? The answer is, they should hit the ground at the exact same time, because horizontal velocity does not impact how fast something falls. If we want, we could rephrase the question as, how far will this red deer fall in 1 second? For that, we're going to use our free fall equation, where the distance we fall is equal to 1/2 times the acceleration from gravity times time squared. In this case, we don't know the distance, so that's going to be x. We know acceleration from gravity, that's always 10. And we figured out the time he's falling down is just going to be 1 second. So x is going to be 5. And that's it. If this deer jumps 5 meters in the air, that will take 1 second up, 1 second down, and that will give the deer the 2 seconds of flight needed to cross this 20-meter ravine.